So in this session, we're going to discuss some data structures that can be used in games. So, uh, so we'll shift our focus to more specialized data structures such as stacks, queues, hash sets, exploring their unique capabilities and applications in programming. So understanding these data structures will enhance your ability to choose the most appropriate tool for various coding scenarios, which is a key skill in efficient programming. So we have stacks. So stacks are a type of data structure that operates on the principle of last in, first out. This means that last element adds to the stack is the first one to be removed. So stacks are particularly useful in scenarios where you need to reverse items or process them in the exact reverse order that they were received. So the key operations here are push, pop, and peek. So push basically adds an element at the top of the stack. Pop removes the top element from the stack. Peek returns the top element without removing it, allowing you to see what is exactly what is currently at the top of the stack. So stacks are commonly used in function call management, uh, parsing expressions like calculators, or for backtracking algorithms like navigating browser history. Uh, we'll discuss more about it, but I just wanted to give you an overview of what stack means. So next is queues. Queues operate on the principle of first in, first out. Uh, this means that the first element added to the stack is the first one to be removed. Queues are essential when you need to manage elements in the order they arrive, such as managing a lineup of tasks or handling operations in real-time processing. The operations here are NQ, DQ, peak. So NQ is basically adds an element to the end of the queue. DQ is removes the element at the front of the queue, and peak, like stacks, peaking in queues lets you see the front element without removing it. So queues are typically used in scenarios like scheduling, like task queues, buffering data streams, excuse me, or breadth first search algorithms in a graph-based problems. Hash sets. Hash sets are a collection type that focuses on uniqueness. Every element in a hash set must be unique, and no duplicates are allowed. They are implemented in a way that makes checking whether an item is already included uh, in the set very efficient. The characteristics for assets is, first one is uniqueness. Only unique elements can be added. Attempting to add a duplicate item will have no effect. Efficiency provides very fast lookup, add and delete operations. So the use cases for assets are ideal for cases where you need to ensure no duplicates are present, such as permission sets or handling a collection of unique user IDs. That's when you can use hash sets. Uh, Hash sets are powerful when dealing with large data sets where the uniqueness of elements are is crucial, and where performance is, in addition, removal or lookup operations needs to be efficient. So understanding these advanced uh, collection types not only adds the skills as a developer, but also uh, deepens your ability to apply the right data structure to effectively solve specific problems. So whether managing the order of operations with stacks or and queues, or ensuring data uniqueness with hash sets, these structures provide robust solutions in both simple and complex software or game development scenarios. Remember, the key to proficiency in programming depends in understanding the properties and appropriate use cases of different tools and technologies. So uh, so let's discuss more about stacks. So in this section, we'll discuss the fundamentals of using stacks in C Sharp, which is a specific type of data structure, as I mentioned, ideal for scenarios where you need access, uh, where you need to access elements in reverse order. So yeah, again, stacks operate on last in first out principle, making them uniquely suited for certain programming tasks compared to other collection types like arrays or lists. So what is a stack? Stack is a dynamic collection of elements that allow you to add or remove elements from only from the top of the collection. So this last in first out approach means that the most recently added element is the first one to be removed. Um, some of the characteristics for stacks is the size of a stack can increase or decrease dynamically, adapting to the number of elements it holds. Uh, and the stacks can store null and duplicate values, providing flexibility depending on your application's needs. And to use stack in your C Sharp programs, you need to include System.Collection.Generic namespace at the beginning of your code file. So this namespace, System.Collections.Generic, uh, contains generic collection types, including stacks, which offer type safety and other benefits over their non-generic counterparts. Uh, Actually, let me okay, trying to pull up the code. Okay. So in blueprint form, it looks like this. So it's the syntax to declare a stack involves several key components. You specify the type of elements the stack will hold using the angle angle brackets, and like other objects in C Sharp, stacks are initialized using the new keyword. So yeah, here's how you can declare a stack that holds integers. So not an integer, but yeah, let me let me uh, let me put an integer. So yeah, you just so for an integer you just you define the element type as int, and yeah, you can declare a stack that holds integers with this line. So yeah, this declaration, uh, let me change the name to my stack. So this declaration creates a new stack of integers called my stack. And unlike arrays or lists, you cannot initialize a stack with predefined elements directly in its declaration. So there are non-generic version, like C Sharp also provides a non-generic version of the stack. Um, let me pull that. Yeah. So this version does not require type specification, making it making it less type safe and generally less preferred due to potential runtime errors and performance costs. The use of non-generic collection is discouraged in modern C# programming, as detailed in the Microsoft's recommendations. So it's about so after you declare a stack, uh, you typically interact with it through several methods, like push, pop, peek. As I mentioned before, push is for basically adds an element to the top of the stack. Pop removes and returns the top element of the stack of the stack. Peek basically returns the top element without removing it, useful for checking the current top element without modifying the stack. So let's look into an example. Okay, so put a string here with sample books is equal to new stack string, sorry. Okay. um, dot push book one, mm, 2, and we string top book is equal to books dot peak, basically returns the returns book 2 because that's the top book in the stack. And let's pop books dot pop removes the book 2, sorry. So in this example, we create a stack books that stores strings, and we add two books to the stack using the push, and we use peek to look at the top book without removing it, which is the book 2, and we use pop to remove the top book from the stack, which is the again book 2. uh, yeah, that's a simple example of how the stacks work. um, Stacks are powerful tool for scenarios where reverse order processing is required, such as undo mechanisms in applications or for parsing expressions. So they're simple but yet effective set of operations, allows for efficient management of data where only the most recently added elements needs to be accessed directly. Uh, Now let's see a real world, another real world uh, example. So in this exercise, we are integrating the use of stack data structure into the uh, Hero Born game to manage a collection of loot items. So this example explains how stacks can be practically applied in game development, particularly for managing collections of objects in the excuse me, in the last in first out order. So let's go back. Okay, so we declare, so this line in the game behavior script, I think we already have a game behavior script. So we start declaring a new stack variable, loot stack, uh, to hold strings representing the names of loot items. So this line creates a stack that is specifically designed to store strings. The stack string, this the stack string type ensures that all elements in the loot stack are strings, providing type safety and preventing errors related to incorrect data types. And then So next we populate the stack with the initialize method. Here's how the items are added. So each push operation adds a new item to the top of the stack. The order in which items are pushed in dictates the last item pushed, which is material braces. Will be the first one accessible for removal, which follows the last in first out principle. So to keep track of what's in the stack, a method print uh, print loot report is added. So this method uses loot stack.count to report how many items are currently in the stack. So it's a simple way to monitor the stack size, which changes as items are added or removed. And then, so in the item behavior script, so this is the game behavior script. So in the item behavior script, we're gonna add this part of the code. Yeah. So in the item behavior script, the stack is interacted with during a collision event when the player collects an item. So when a player collides with an item, the item is destroyed, simulating collection, and the print loot report is called to log how many items are left in the stack. So this setup doesn't doesn't yet utilize the pop or peek methods to remove items or check the next item directly, but sets the stage for such operations. So this setup demonstrates the initial phase of integrating a stack to manage game items dynamically. So the next logical steps would be use the pop method when an item is collected to actually remove the top item from the stack. And optionally, you can use the peek method to if you need to show the player what next collectible item will be without removing it from the stack. So by using a stack for item management, the game can maintain a robust system that handles item collections and access in a controlled, predictable manner. So this enhances the gameplay experience by adding an element of depth and strategy uh, to how items are used and collected. Next, we're gonna continue. So here we'll explore two fundamental methods used to interact with items in a stack, which is peeking and popping. So these methods are crucial for efficiently managing the order of items in scenarios where last in first out approach is appropriate, such as undoing actions in applications or processing tasks in reverse order. So as you know, the peek method allows you to view the top item of the stack without removing it. So this is useful when you need to check what the next item to be processed is without actually changing the stack's state. And it's often used in conditions where next item's value needs to be known for decision making without disrupting the stack's order. And the pop method, as in the pop method, not only returns the top item from the stack, but also removes it from the stack. It This method is essential when you need to process and remove items in the order they were last added. So commonly used in scenarios like undo mechanisms where the most recent actions needs to be reverted. So the practical implementation for this in game development is, so let's apply these concepts to the hero born game. So to manage the a collection of loot items using a stack, uh, so so here so Yeah, it's the same code. It's the same method, print loot report, but I'm gonna just add a new set. But yeah, here first step is the pop method. Uh, the pop method is called first to remove and retrieve the last item added to the loot stack, which is the what is it? The this one. So that this item is stored in the current item, and immediately after popping, the peek method is used to view the next item that would be removed if pop were called again. So this item remains in the stack and is stored in the next item. And the debug log statement is used to inform the player about the item they just collected, which is the, where is it, yeah, current item, and and hint at what the next collectible item, which is the next item, will be. Another log statement provides a count of how many items are still available in the stack. So upon executing this function, the console would display messages indicating that the player has collected metal bracers and hinting that wing boots is the next item in line. Uh, Additionally, it confirms that four items remain, providing a transparency about the loot availability. So using peek and pop in tandem allows for sophisticated management um, of game elements where the order of interactions or events is critical. So in the context of Hero Born, so this approach enhances the gaming experience by adding an element of strategy and anticipation for players as they collect items. So the implementation of these stacks methods demonstrates a practical use of stacks in game development where managing ordered elements dynamically can significantly impact gameplay dynamics and player engagement. So yeah, so there are some stack operations. In this part of our discussion, we focus on common methods provided by uh, uh, stack T class in C sharp, which allows for more versatile management of stacks contents. So these methods enhance the functionality of a stack, making it not just a structure for storing items, but also a dynamic tool for manipulating and accessing those items. Um, Here we have a method called clear. So the purpose of clear is it completely empties the stack or of all its elements, resetting its count to 0. So this is particularly useful when you need to discard all current items and start fresh. Example is loot stack dot clear, which empties the stack, and we have another method contains. Uh, the syntax is basically contains t item. The purpose of this is it checks if a specific element exists within the stack, returns true if the item is found, otherwise false. So this method is useful for conditionally performing operations based on the presence of an item. um, Let me, yeah, so this is an example. It checks for golden key and returns true or false if, depending on the stack. And what else we have copy to, which copies all elements from the stack to a specified existing array starting at a given index. So this method is useful when you need to work with stacks data in an array, in an array format for operations that require array structures. Example, let me so yeah, this is an example. It This line copies items to copied loot array starting at index 0. Yeah, and yeah, so that's about copy to and to array, which basically converts the entire stack to a new array. So this differs from copy to, as it creates a new array instance rather than requiring an existing one. Example, yeah, to array. Yeah, it creates a new array from a stack. We have a next one is we have a string to string. Where is it? Yeah. To string returns a string that represents the current object in the base of stacks. So this generally returns the namespace and the type name of the stack, not the contents. Uh, yeah, example is this one. Basically gets string representation of the stack object. Uh, Next is safe element access. We have try peek and try pop. These methods provide a safe way to access elements at the top of the stack without causing exceptions if the stack is empty. So the return true if an element is present, and also the return the element itself using the out parameter, or false if the stack is empty. Uh, Let us look at an example for this. Yeah. So yeah, this is an example for try peek and try pop. So yeah, it's similar to the concept. Item will not be removed from the stack. It removes the item. Uh, and so the functionality provided by these common stack methods allows us to manage the stack's contents efficiently and perform a variety of operations ranging from simple checks to complex manipulations and safe access patterns. So by integrating these methods, we can ensure that their stack based logic is robust and efficient and error resistant, making the stack a highly flexible and powerful data structure in C Sharp. Uh, we'll discuss about queues and hash sets in the next session. That's all for today.